This is a first video for section Vrap F. In this video we're looking at inverse variation. Now if y is inversely proportional to x, then we have what we see in this box here. So y is proportional to 1 over x. That means the inverse. So that means y equals k over x. If it helps, if y is proportional to 1 over x, that means y equals k times 1 over x, which can be written like that. Now if two variables x and y vary inversely, the product of the variables is constant. So xy equals k. So you can see from here, if I have y equals k over x, if I multiply both sides by x, I end up with xy equals k. So that means that as one variable increases, the other will decrease. Furthermore, inverse variation may also occur when one quantity varies with some power, so square, cube, square root of, etc., of another quantity. And you can see that expressed here. So very similar to what we had with direct, but now it's 1 over. So let's look at an example. If d varies inversely with the square of m, so d is proportional to 1 over m squared, so d equals k over m squared. So it says when d equals 81, m equals 1.2, so I can plug that in. So 8 equals k over 1.2 all squared. So that means k is going to be equal to a times 1.2 all squared. We're just timesing both sides by this 1.2 squared. Plug that into the calculator and get 116.64. So therefore d equals k, which is the 116.64 all over m squared. And that's your relationship. Next, if z is inversely proportional to the square root of f, so z is inversely proportional, so 1 over the square root of f. So that means z equals k over the square root of f. The information it tells me is z equals 1 when f equals 9. So 1 equals k over the square root of 9, so 1 equals k over 3. Times both sides by 3 to get k on its own, and you get k equals 3. So therefore z equals 3 over the square root of f. Now it says another part, you would keep working down the page yet again, but I've run out of room. So 3 over the square root of f. Find z when f is 25, so it's going to be 3 over the square root of 25, which is 3 over 5. Let's look at an application problem. This one says in a belt drive system, the speed at which a pulley rotates is inversely proportional. So speed is inversely proportional to the diameter of the pulley. The belt drive system shown consists of pulley A driving double pulley B, which in turn drives pulley C. Given that pulley A with diameter of 20 centimeters is rotating at 480 revs per minute, so that means diameter 20 centimeters gives a speed of 480 revs per minute. Find the speed at which pulley B is rotating given its diameter is 60 centimeters. Sounds confusing, but let's start at the beginning. Let speed equal s and diameter of pulley equal d. It starts by saying the speed at which the pulley rotates is inversely proportional to the diameter. So s is proportional to 1 over d, which means s equals k over d. Now it also gives me that when I've got pulley A, the diameter of 20 gives a speed of 480. So if I plug that in, I get 480 equals k over 20. So k must be 480 times 20, which gives me 9,600. So my formula is s equals 9,600 over d. Let's put that up here so you can see it a bit better. So s equals 9,600 over d. It then says the speed at which pulley B is rotating giving its diameter is 60. Well, we can use this general formula to look at that. So the speed of B is going to be 9,600 over 60, which is 160 revs per minute. Again, finish with a therefore statement, but I don't have enough room. Next, the diameter of pulley C, given that it's rotating at 180 revs per minute. Again, write the general formula out. Now, the speed of C is 180. Find the diameter of C. Swap these over. I get the diameter of C is 9,600 over 180, which is equal to 53.3 recurring. Finish with a therefore statement. Okay, so a problem that sounded really complicated, if you break it down and start with the basics, you should be able to do it. So what now? There aren't any exercises yet. We haven't covered enough material. So move on to Vrap F Part 2 video.